All right, in the past couple of slides, we discussed the different types of SQL injection vulnerabilities. Now in this section, we'll discuss how to find SQL injection vulnerabilities. So imagine you've been given an application and asked to test it. How would you go about testing the application to see if it's vulnerable to any SQL injection vulnerabilities? Before we cover that, it's worth mentioning that the methodology used for finding SQL injection vulnerabilities differs from one person to another person, and it's usually developed by experience. So just because I give you my methodology doesn't mean that you have to follow it to the letter. Instead, I would recommend that you take what is useful for you from it and then build and add on to your own methodology as you gain more and more experience in pen testing web applications. Okay, so finding SQL injection vulnerabilities, I've decided to split this into two categories depending on the perspective of testing. And the two categories are black box testing and white box testing. For those of you that have never heard of these terms before, black box web application pen testing is when the tester is given little to no information about the system. Usually the only information that the tester has access to is the URL of the application and the scope of the engagement. So this is similar to mimicking an external attacker that is trying to attack your system. The attacker usually doesn't know anything about the application other than the main URL of the application. Now for white box web application pen testing, it's the complete opposite. The tester would be given complete access to the system, including access to the source code of the application. Now there's a third category that I haven't included on the slide, and it's called gray box web application pen testing. This is a combination of white box and black box pen testing where the tester is given limited information and access to the system. For example, instead of just giving the tester a URL of the application, like you would with black box pen testing, the tester is also given accounts to the application. So when it comes to my methodology of finding SQL injection vulnerabilities, I loop both gray box and black box pen testing into one category, and that's because my methodology is the same regardless of the category. The way I see it is if I'm approaching it from a black box perspective, my scope will be much more limited than the gray box perspective unless I find authentication bypass vulnerability. Nevertheless, the methodology is still the same for finding SQL injection vulnerabilities, whether I'm doing it in public or an authentication page. And that's why they're looped in together. Now, when it comes to white box pen testing, that's a whole different methodology because you actually gain access to the source code of the application. And reviewing source code is a whole different realm than approaching an application from the outside. All right, let's start off by talking about how to test applications from a black box perspective. The first thing that I do when testing an application is map the application. And what that means is I literally visit the URL of the application. I walk through all the pages that are accessible to me within the user context that I'm running as. I make note of all the input vectors that potentially talk to the backend. I understand how the application functions. I try to figure out the logic of the application. I try to find subdomains in the application. I enumerate directories and pages that might not be directly visible to me through the application, and so on. And while I do all of that, I have my burp proxy listening silently and intercepting all the requests that I'm making to the application. So mapping the application is such an underrated step when it comes to pen testing applications, although I would argue it's probably the most important step. And the reason I say that is because I usually see beginners in this field get way too excited about the fact that they're testing an application, and then the first thing that they do is start throwing potentially malicious input vectors into the application to see if the application responds in an unusual way. And although this is a valid way of testing an application, it doesn't make you any different from an automated tool. So this is exactly what web application vulnerability scanners do. They crawl the application, they locate all the input vectors, and then they throw a ton of malicious payloads at these input vectors. And depending on how the application responds, the scanner logs the behavior as a potential vulnerability. And this way of testing usually only discovers the low-hanging vulnerabilities. So if you're doing exactly what a scanner can already do, then your testing is really not adding any value. Instead of doing that, what I would recommend is you leave that up to the scanners and instead spend quite a bit of time understanding how the application works, because most of the critical vulnerabilities found in applications are logic flaws that a scanner is not capable of finding on its own, or the vulnerabilities are embedded in pages that the scanner can't crawl, so technologies that the scanner can't crawl. Okay, so once you've mapped the application and you've listed all the input vectors that are potentially included in queries that are interacting with the SQL database, then it's a matter of fuzzing the application. And that's because we're looking for SQL injection vulnerabilities. You'd be fuzzing the application with SQL-specific characters. So what that means is you add special characters in the input vectors and see if the application responds in an unusual way. Now, depending on how the application responds, you start refining your query until you achieve your end goal. And that's what makes you different from a scanner, because a scanner just simply throws a bunch of input at the application. You as a human being you're capable of understanding the output of the SQL injection. And so you're able to refine your SQL injection using multiple requests until you actually achieve your goal. And we'll see how to do that in the exploitation section of this video. Okay, again, fuzzing the application means adding special characters and input vectors and seeing if the application responds in an unusual way. Now, that can be done in many ways. The first thing that I try to do is submit SQL-specific characters, such as the quote, or the double quote, or the hash, or the dashes that represent comments, and see if the application outputs an error. Now, errors are really important and really useful because they give you information about how the backend operates. So sometimes they give you the database that you're using, they give you the version of the database. We discussed that sometimes they actually give you the exact query. If they gave you the query, then you hit gold, because this way you don't have to develop your payload across multiple requests. Instead, you already know what the backend query is, and so you just develop your payload based on that query. And so the first thing that I do is try to output an error. Once I have an error, I try to build my query using multiple requests. So I refine my query based on the errors that I get, and I build my query. Now, in certain scenarios, you don't actually get an error, like for blind SQL injection. And so you also have to submit Boolean conditions, such as, and or 1 equals to 1 and 1 is equal to 2, and look for differences in the application's responses. So if you can get the application to respond differently when you force a true use case versus when you force a false use case, that means it's vulnerable to Boolean injection. Next, I do the same thing as Boolean injection. Instead, it would be to trigger time delays in the application and then see if there's a difference in the time it takes to respond. So if you input a function that causes a time delay and you actually observe that time delay, that means that the application is vulnerable to time-based SQL injection. Last but not least, I also submit out-of-band payloads that are designed to trigger a network interaction with a server that I control. And if I get that network interaction, whether it's a DNS lookup or it's done through HTTP, that means that the application is vulnerable to out-of-band SQL injection. And if I don't get them, that means it's not vulnerable to out-of-band SQL injection. That's a high-level overview of my methodology when it comes to testing from a black box perspective. There's really 2 steps. First, mapping the application. So listing all the input vectors in the application, and then fuzzing the input vectors to see if I can find a SQL injection. And again, when it comes to fuzzing the input vectors, you can refine your requests based on the responses that the application gives you. Okay, next is white box testing perspective. So where you're given the source code of the application. In this case, the first thing that I do is I enable web server logging and I enable database logging. So enabling logging at the web server level will help because when you're fuzzing the application, like we did with black box perspective, it will generate errors on all the different invalid characters that you input into the application. And then that helps you to detect that SQL injection exists, and then also to refine your payload later on. Similarly, for database logging, I enable that because when I think that there's a SQL injection vulnerability and I enter a SQL injection payload in the parameter, I'd like to see how it was logged at the backend. And then depending on how it was logged at the backend, I can see what characters made it through and in what format they made it through. And then I could say with maybe a 90% accuracy that yes, this is vulnerable to SQL injection before I even look at the source code of the application. So once I have my logging enabled, the next thing that I do is map the application, just like I would with a black box perspective. So I'll start with the application's graphical user interface. I'll map all the visible functionality in the application, all the input vectors that potentially talk to the backend. Next, because I do have access to the source code, I'll also do a regex search on all instances in the code that talk to the database. And that really depends on how the application is programmed and then which database it uses and so on. But I would have regex strings that I look for in the code to see if I've missed anything that I haven't mapped from a black box perspective. And you'll see that there are certain pages that might not have been directly accessible through the main page of the application, and you didn't discover them through directory brute forcing. And so it's useful to actually look at the code and see if there's anything that you missed. Once I have a list of everything, what I would do is I would literally fuzz the application. So I would submit SQL characters that could potentially break the query. I will look at how they were logged using database logging that I enabled in the first step. And then based on that, I can usually tell if it's vulnerable to SQL code injection. And if I feel like it's vulnerable to SQL code injection, then I actually do a code review of that functionality. So for example, if I think the login page is vulnerable to SQL injection, what I would do is I will look for the login functionality, so the function that implements that in the code, and then I would do a walkthrough of that entire functionality from beginning to end, until I have confirmed that it is vulnerable to SQL injection in theory. And then to confirm in practice that it is vulnerable to SQL injection, then I would test it out. And depending on the response I get from the application, that means it's vulnerable to SQL injection. So again, that's my methodology. It doesn't mean that it's a methodology that you should follow. I do know people that would automatically just go into the source code and then do a search for insecure functions when it comes to parameterized queries and so on. And so if they find an insecure function, they'll start with that instead of doing kind of a hybrid approach of both black box and white box, which is the methodology that I described.